Algebra 2, 3.2, 3.2, 7.3, polar functions and function operations. So what we're going to do is we are going to now just add, subtract, multiply, and divide fractions. So they have it here is what it looks like, and they also kind of give you an example here of what that would look like at the end. Biggest thing about adding, subtracting, multiplying, dividing your polynomials or functions is that they are polynomials and you treat them like adding, subtracting any other polynomial. So you make sure you use parentheses first, then you can get rid of parentheses after if they're not needed to gather up like terms. So addition, all I'm doing is taking here that a new function arrives when you do things, but f of x plus g of x. Now, I'm going to squeeze in here a different way to write this, because they sometimes write this as f plus g of x. So they don't always write f of x plus g of x. They try to save a little bit of ink and a little bit of time. And so you might see it as f plus g of x. Same thing applies for subtraction. F minus g of x. And multiplication, f times g of x. And notice that the x is like factored out. It was taken and put it on the back. Okay? And h of x, f of x divided by g of x, it would be f over g of x. So those are all different ways to see the same thing. Now for the dividing one, you have to be careful that if you're dividing your polynomials, you still have to reduce them. If there's a common term on top and the bottom, you need to cancel to make sure it's good. And it says on the bottom that the domain of H consists of the x values that are in the domains of both f and g. Additionally, the domain of the quotient, the dividing one, also says you can't have the bottom ever equal 0 on a fraction, right? So therefore, it still includes the x values that you're allowed to put in f of x and g of x, but then also one more restriction where x can't be 0, or what? X can't be 0. X can be 0. It's what the function g of x can't be 0. Because if you make g of x equal 0, then you're dividing that fraction by 0. So let's put this to practice. What we have here is f of x and g of x. F of x equals 2x to the 1/2, and g of x is negative 6x to the 1/2. I want you guys to add them, subtract them, multiply, and divide them. So let's start off with the addition. And so what I'm going to do is I am just going to use my substitution skills, and I will replace f of x with what it equals. What does f of x equal? 2x to the 1/2. Guess what I'm using? Parentheses. And g of x is negative 6 to the x 1/2. And the parentheses. Then you kind of sit back and say, after you look at this, you evaluate, do I need those parentheses? So we don't need the parentheses, and so it becomes 2x to the 1/2 plus a negative 6x to the 1/2. Hey, wait a minute. Those are like terms. They're both 1/2 powers. If I have 2 of them and I'm adding a negative 6 of them, I have what? How many of them?
2.
No, not 2.
1.
No.
Half.
No.
4, 5, 6, 7, 3, 2.
What's 2 minus 6?
3. 4.
Negative
4.
4x to the 1/2. So when I add them together, I get a negative 4x to the 1/2. Remember, we're gathering like terms, so the coefficients is all I'm looking at. 2 plus a negative 6. F of x minus g of x is going to end up being the same thing. Got to use those parentheses. But when I do this, that first group, don't need the parentheses. The second group, though, I need to take the negative and bring it in. And a negative of a negative is a
Positive.
positive. What's 2 of something plus 6 of something? Ends up being 8 of something. So you get 8x to the 1/2.
Why is there an arrow?
For multiplying, I am going to sub in the groups again. But the operation between them is multiplying. In this case, I'll leave the parentheses there, knowing that I'm going to do the coefficients first. What's 2 times negative 6? It's negative 12. And x to the 1/2 times x to the 1/2 is x to the first, or just x. And there's your answer. The last one's using parentheses. We're going to divide them. 2x to the 1/2 over negative 6x to the 1/2. The nice thing about dividing is that technically the division symbol itself can act like the grouping symbols. So I'm not going to clutter these ones up with the extra set of parentheses, but I still can reduce them. I simplify them. I have x on top and an x on the bottom. That's x to the 1/2 divided by x to the 1/2. What does that become? What does that become? What's x to the 1/2 divided by x to the 1/2? What's something divided by itself?
1.
1. Don't need to write it. What's negative? Oh, it's 2 divided by negative 6. That can be reduced
Negative.
to 1 over negative 3. And your answer is negative 1/3. Okay. So we have composition of functions now. The composition of functions looks like 2 different things here. Or there's 2 different ways when you have functions. You have f of g of x, and you have g of f of x. You know what? I'm going to back this out.
Could I just scroll on?
No, you can leave it. I'm just going to color code mine. This would be g of x, and this is f of x. The reason why I want to color code this is because what you're doing with composition is placing one function inside of the other. Okay? So what we're going to do is you're going to follow whatever the problem says. So here we go. We have f of x equals 3x to the negative 1 power. We have g of x, which is 2x minus 1. What we're going to ask you to do is f of g of x. So I want you to do f of g of x. So the way I like to think of this is like I'm transplanting flowers. So if I'm going to transplant a flower, I'm going to take my shovel and I'm going to dig out the old plant, right? And when I do that, what's left? A hole or a void, right? And what's going to happen is I'm going to put in there something else. So that's what's going to happen. In this particular problem, f of x is where the old flower is coming from. And what particular part of it? The x. Because normally it's supposed to be f of x. So x is the old part. I'm going to take them out. So what I do is I go back and I write down f of x. But anywhere there was supposed to be an x, I'm going to put parentheses and leave it blank. I then go back and I fill it in with whatever, in this case, g of x is. And g of x was 2x minus 1. You just did composition. Now, if that didn't have a negative 1 power on it, then I could actually distribute the 3 and gather like terms. Because of the negative 1 exponent, we're going to leave it. So the question is, what if I gave you g of f of x? Using the same reasoning, f of x, or g of x, sorry, is my outside function, the bigger one. So I write that down first. And that was 2 times something minus 1. And that something was supposed to be an x. Do you see that from here? What's going to go where x was? F of x is 3x to the negative 1. Now in this particular problem, I am not done. I need to simplify it. I have 2 times the quantity of 3x to the negative 1. So that means I can take the 2 and the 3 and multiply them together, and there you go. That's composition.